friends, in this video we are going to study about how the memory devices, memory chips, they are interfaced with the 8086 microprocessor. So let us start with our topic. We know that memory, it is an integral part of the microprocessor. Memory is used to store the program, it is also used to store the data, and all the important things, they are stored in the memory. So it is for the storage of data or instructions or programmed for the microprocessor. Now this memory, it can be of two types in the case of microprocessor. It can be ROM or RAM, that is random access memory or read-only memory. Now this read-only memory, it can only be read. So for this ROM, we have only the read signal available. Means read operation will be associated with it. Whereas this random access memory, we can read and write this memory. So we have both read and write signals for it. So this read-only memory, it is available for the reading purpose only, and it stores the, it is programs. Means at the time of manufacturing, we store the main programs in the read-only memory, those programs which do not need any alterations. So programs that do not need changes, they will be stored in the read-only memory, and the random access memory, it is used for the storage of temporary data and also for the storage of users program, means the program which are made by the user. Now under the category of ROM, we have different types of memory like PROM, EPROM and EROM. EEPROM. That is programmable read-only memory. This is erasable programmable read-only memory. Then this is electrically erasable programmable read-only memory. So we have different types of ROM available which can be used to store the system softwares and the system programs and data that will be present here in the read-only memory. We can only read that data, no write operation is available, so no modifications can be done in these programs. Whereas the random access memory, because this memory we can read and write, it is used to store the temporary data and the user's program. So we can say that this memory is the volatile memory. Okay, modifications can be done in it. So these are the two types of memory available for the microprocessors. Now when the microprocessor, it wants to read or write the data from the memory, it has to communicate with the memory. Okay, so for microprocessor, we have a memory chip, and here we have the microprocessor. So this microprocessor, it is either going to read the memory or it is going to write the memory. It is going to read the data from the memory chip or it is going to write the data into the memory chip. So first this microprocessor, it has to communicate with this memory chip. Now this communication, it is also known as an interface. So in this video, we are going to study the interfacing techniques, that how the memory is interfaced with the microprocessors. Now for this interfacing, we will need two signals, one for the read and one for the write. The microprocessor, it is going to initiate these signals, read and write signals, so that data can be read or written into the memory chips. So microprocessor, it needs to access the memory to get the instruction codes and the data. Codes means the programs are written in the memory. So those programs, if the microprocessor it wants to access the instruction, fetch the instructions, then that will be done from the memory, and also the data that is stored in the memory. So if we want to access the memory, it will initiate the read and write signals. So according to the operation which the microprocessor wants to perform, according to that operation, it is going to initiate the read and write signals. So for read, it has the MEMR, that is memory read, and for write, it has MEMW. So we have memory read and memory write signals. Memory read signal will read the memory, and memory write, it is going to write the data into the memory. Now which memory, because the memory chips, there can be many number of memory chips connected to the microprocessor. So which memory chip it wants to connect, and from which memory chip it wants to read the data or write the data. So there is should be some logic which can select the chips, that which memory chip it wants to communicate. So if this is our microprocessor, we will have different memory chips. Microprocessor can communicate with any of the memory chip. Suppose this is chip number 1, chip 2, chip number 3. So every chip will have this microprocessor will have the read and write signals, and also every chip will have a chip select signal through which these chips can be selected. So the microprocessor, if it want to communicate with these memory chips, and so for each memory chip it should have a chip select signal. CS is the chip select signal, so that with whatever memory chip it wants to communicate, it can select that chip, and for that chip, if it wants to read the data, then read signal should be there, and if it wants to write the data into that memory chip, then write signal is there. Now for this type of communication of the microprocessor with different memory chips, there is a need for a device or a circuit which can perform these chip select and the read and write signals, which can provide these signals. So this type of circuit or device is known as the memory interfacing device. So to do the above job, it is necessary to have a device or a circuit which performs this task of reading and writing into the memory or selecting the memory chips, and that device is known as the interfacing device. Now this device, because it is linked with the memory, that is why it is also known as the memory interfacing device. So this memory interfacing device this device basically interface the memory with the microprocessor. So here we will have the microprocessor, then we will have memory, and the interface, that is the path of the communication between this microprocessor and memory, it is provided by the memory interfacing device. Now this memory interfacing, it basically involves three different tasks. These tasks are: first, so because the microprocessor, whenever it wants to read or write into the memory, then it will use the memory interfacing device. Now this device, it performs three different tasks. First, it is going to select the required chip, because the memory, it will be available in the form of different memory chips are there. So which memory chip is required, that will be selected. So first task will be to select the required chip. Then to identify the required register. Now memory, it is composed of various memory registers, and these memory registers, they have different memory locations. Addresses are defined for each register. So the next step will be to identify the required register, which means first the memory chip will be selected, and in that memory chip, which register we want, from which memory register we want to read the data or to write the data, that register will be identified. Third step will be to enable the appropriate buffers. Now when we want to the microprocessor want to read the data, so read signal has to be activated, and if it wants to write the data, then write signal has to be activated. So appropriate buffers like data buffers, address buffers, read and write signal, whichever signal is to be activated, that will be the third step. Okay, so in this way the interfacing is done between the microprocessor and the memory. Okay, now let us study a simple memory device, that how a simple memory device will consist of, what are its input and output lines, address and data lines, what is its configurations. Let us see. So any memory device, it will consist of address lines, input output lines, selection input and control input. Okay, this is a simple memory device in which we have the address lines from A0 to AN. Then we have input output lines from input output 0 to input output N. Then we have the selection input, that is the chip select signal, and control inputs are the read and write inputs. These inputs will enable the microprocessor to read or write the data into or from the memory device. So let us study that how many address lines and input output, what is the function of these four components of a memory device. First, let us come to the address lines. So the address lines are the address inputs which select the memory location within the memory device. Now in this memory device there are various registers and each register is capable of storing a bit. Okay, so these registers, how these registers will be selected, these register will have a particular memory location and that memory location is specified by the address lines. So these address lines, they select the memory locations, they provide the address of that memory location within the memory device. Now these address lines, they are denoted from A0 to AN, and the number of address lines, they define the total capacity of the memory, that how many what is the storage capacity of this memory. So the number of address lines, so the number of address lines, it will indicate the total memory capacity of the memory device. Suppose we are having a 1 kilobyte memory. So this 1 kilobyte memory, it will have 1024 bytes will be there. 1 kilobyte equals to 1024 bytes. Okay. So this will be equal to 10 address lines. So to address this 1 kilobyte memory, 10 address lines are required. And suppose if we are having 1 megabyte of memory, then 20 address lines are required. So you can say that the number of the address lines, it indicates the total memory capacity of the memory device. If we are having 10 address lines, means that the memory device, it is having the storage capacity of 1 kilobyte. If it is having 20 address line, that means it can store 1 megabyte of the memory. Okay. So this was about the address lines. Next we have the input output lines. So the memory device, it may have separate input output lines or a common bidirectional input output lines. Now this memory, it is used, microprocessor, it writes the data or reads the data from the memory. So that data will be available on these input output lines. Now the memory device, it can have separate input lines and separate output lines, or it can also have a common bidirectional input output lines. So if it is having the bidirectional input output lines, so these lines can be used to transfer the data in any direction, that is from microprocessor to the memory or from the memory to the microprocessor. So a single line, it can act as an input line also and as an output line also, and these lines, they are denoted as input output 0 to input output n. So n is the number of the input output lines. Because these lines, input output lines, it is carrying the data, so we can also denote this like D0 till Dn. So we can say that these are the data lines, because it is carrying the data from the memory device or to the memory device. Now the data lines, they are from D0 to Dn. So we can say that there are n data lines. Now size of a memory location, it is dependent upon the number of data bits. Like here, if we are having the number of data lines as 8, that is from D0 to D7, then it is having 8 bits. Okay, so 8 bits can be stored at one memory location. Okay, suppose this is our complete memory. This memory is divided into different registers. Okay, or we can say that these are different memory locations here, 1 2 3 till the memory size of the memory device. Now each, because here we are having the number of data lines as 8, it means 8 bits can be stored at a single memory location. It can be stored in each location. So 8 bits are stored here. Again 8 bits are stored at second memory location, then at third memory location also 8 bits are stored. So in this way, at each memory location 8 bits can be stored. So we can say that size of a memory location, it is dependent upon the number of data bits. Now suppose if the number of data lines are 16, that is from D0 to D15. So it means that 16 bits can be stored here, 16 bits, or we can say 2 bytes. Okay, so in this way, the number of data lines, it is deciding the size of the memory location, and number of address lines, it is deciding the size of the memory device. So this thing you can keep in mind, that number of address lines indicates size of memory device, or we can say memory chip, and number of data lines indicates the size of memory location. So suppose that a memory chip, it is defined like this. We are giving the size 2K into 8. If we are given a memory chip that it is of the size 2K into 8, so it means that the size of the memory device is 2 kilobytes, and each memory location can store 8 bits. Okay, so it is 8 bits can be stored, and 2 kilobytes means 2 kilobyte is the size of the memory size, we can say. So we know that 1 kilobyte is equals to 1024. So 2 kilobyte will be equal to 2048. So we can say that there are 2048 memory locations, and each memory location can store 8 bits. Okay, so this is how, whenever we are given the memory chip whose specification is given like this, we can determine the memory size also, and the number of bits that can be stored at each memory location, that can also be identified. So this was about the address lines and the data lines. Next come the selection input. Now this selection input, that is the chip select signal, it is used to select the memory chip. Okay. So memory devices, they may contain one or more inputs which are used to select the memory device or enable the memory device. So if it is used to select the memory device, it is known as the chip select signal. That is CS bar. and if it is used to enable, we can denote it as chip enable signal CE bar. Okay, so because we are having a bar over it, means it's an active low signal. It will be active when its value will be 0. Okay, so when we are having 0 at this pin, at this chip select pin, it means that that memory device has been selected by the microprocessor. So every time whenever we want to communicate with that memory chip, this chip select signal has to be enabled. It has to be at logic 0. Okay. So if we are having logic 0, chip is selected, or we can say that it is enabled. And if it is at logic 1, then chip is not selected or disabled. Now here I have written that the memory devices, they may contain one or more inputs. Okay, so these chip select signal, there can be a single line for the chip select signal, or it can be more than one. Okay, so if there are more than one chip select lines, then all the chip select lines has to be enabled. They have to be activated to select the chip. So all pins, if there are more than one chip select pins, then all the pins have to be activated to select the chip. So if we see in the diagram for the memory device, we have the chip select signal which is used to select this memory device. Okay, we have the address lines, we have the input output lines. Now next we have the control input. So control input involves the signals read and write. These signals are used to read the data from the memory or write the data into the memory device. So there can be one or more control inputs. Now if we have the ROM type of memory, means read-only memory is there, then we have one control input signal also, which is known as OE bar, that is output enable pin. Now this enable pin, it also has to be activated if we want to communicate with the read-only memory. This, because this signal, it allows the data to flow out of the output data pins. So for the read only memory, both the output enable and the chip select signal, they have to be activated if we want to read the data from the read only memory. Now these control inputs we are having as the read signal and the write signal. So for read we are having RD bar, and for write we are having WR bar. Okay, so this signals, because it is having bar, so it means that they are activated when its value is 0. So when RD bar is activated, then the data will be read from the memory. When write is activated, it means that the data will be written into the memory. Now if we are having the read only memory, then for this we will be having only the read signal, no write signal will be associated. If we are having RAM type of memory, that is random access memory, so for that we will have both the write and the read signal. Okay, so if we see this memory device, it will have these components: address lines, input output lines or the data lines, chip select signal or the selection input signals, and the control input. Now, whenever the microprocessor it is interfaced with the memory device, then what are the steps that are taken? Let's see this. Now the memory devices, the memories in the microprocessor, they are organized as two-dimensional arrays of memory locations. So in the memory, we have different memory locations, or we can say we have the different register which are storing the data. Okay. Now if we are defining a memory by 4K into 8, so I have told earlier also that 4K it is the size of the memory and 8 it is the size of the data that can be stored at each memory location. So 4K means that the total size of the memory is 4 kilobytes. We know 1 kilobyte equals to 1024. So 4 kilobyte will be equal to 4 into 1024, that is 4096 memory locations. So this 4 kilobyte of memory, it will be having 4096 memory locations, and each memory location can store 8 bit of data. Now to address these 4096 memory locations, we will require the address lines, and because each memory location is storing 8 bit of data, so we will require the data lines. So this 8, it indicates the number of data lines, so we can say that it will have 8 data lines, that is from D0 to D7. So 8 data lines, that is from D0 to D7, will be required to store the 8-bit data. Now we are having 4096 memory locations. So how we will determine the number of address lines using this information? Here we can find out this by, if we are having n memory locations, and suppose the device is having small n address lines. So we can calculate it, we can relate the memory locations and address lines by using the formula small n equals to log to the base 2 capital N, where n was the number of address lines and capital N, it is the number of memory locations. So n, if we want to determine the number of address lines, we are having the number of memory locations as 4096. So we will write here 4096. Okay. Now when we determine this, we will get the, or we can say that 2 raised to the power n equals to capital N. If we take the logarithm on both the sides, then we will get 2 raised to the power n equals to capital N. So 2 raised to the power n will be equal to 4096. And we will get the value of n as so if we calculate this, we will get the value of n as 12. Okay, so 12 address lines will be needed to address the 4 kilobyte of memory, and 8 data lines will be needed to store the 8-bit data. So by using this formula, we can find out the number of address lines when we have the number of memory locations with us. So we can use this formula, and also we can use this formula. So here small n will be the number of address lines, and capital N will be the number of memory locations. So for the 4 kilobyte of memory, we are getting the number of address lines required to address the 4096 memory locations as 12. So 12 address lines will be needed. Now suppose the microprocessor, like we are studying the 8086 microprocessor. So 8086, it is having 20 address lines. From A0 to A19. Now out of these 20 address lines, only 12 address lines will be required to address these 4096 memory locations. So if we are interfacing the 8086 microprocessor with a 4 kilobyte of memory, then we will require only 12 address lines, that is from A0 to A11. So what about the remaining address lines? We can use the remaining address lines from A12 to A19 to form the chip select signal. Okay. So this chip select signal, because we want to select the chip also, so we can use these remaining address lines to form the logic for the chip select signals. So if we are having n address lines, we can use p address lines for addressing the memory location, and we can use the remaining, that is n minus p remaining address lines to form the chip select signals. So whenever we are having this type of questions where we are asked to interface a memory chip with the microprocessor, we will calculate that how many number of address lines we require to address that memory chip, and the remaining address lines we can use to form the chip select signal. Okay. Now let us study the steps which we will perform when we are interfacing the memory with the microprocessor. Or we can say that let us study the general procedure of memory interfacing. So step number 1, when we are interfacing the memory with the 8086 microprocessor will be now the first step will be to arrange the available memory chips so as to obtain the 16-bit data bus width. Because the 8086 microprocessor, here we are studying the memory interfacing with the 8086 microprocessor. Okay, so 8086, it is having a 16-bit data bus width. Okay, so we are going to arrange the available memory chips. Most of the memory chips, they are having the size cross into 8, means into 8 is there, that means 8-bit data can be stored at each memory location. Now we want that 16-bit data should be stored. Okay, because our microprocessor, it is having 16-bit data lines, so we are going to arrange the memory chips so that we can get a complete 16-bit data. How we can get this? The upper 8-bit bank, we are going to arrange two memory chips here. Suppose each memory chip is having the size 1 kilobyte into 8. Means each memory chip, its memory location can store 8 bit of data. So we are 8 and 8 bits, it will be total 16-bit data. So the upper 8-bit bank will be called the odd address memory bank, and the lower 8-bit bank will be called the even address memory bank. So here we are having two. Upper will be called the odd memory bank, and lower one will be called the even address memory bank. Okay, so in this way we are going to arrange the available memory chips so that we can get the complete 16-bit data width. Upper will be called odd and lower will be called the even. Okay, so that will be the first step. Second step will be second step will be to connect the available memory address lines. Will calculate that how many address lines will be required to address that memory chip. Now address lines are available with it, and we know that 8086 is having 20 address lines. So we are going to connect the available memory address lines of the memory chip with those of the microprocessor. Means we are having let's take the example of 4 kilobyte of memory. We were requiring only 12 address lines. So 12 address lines we will connect with the 12 address lines of the microprocessor. Suppose this was our memory. It will have A0 to A12. A11, sorry, we will need 12 address lines. So these address lines will be connected with the address lines of the microprocessor, that is from A0 to A11. Remaining lines we are left with A12 to A19. Okay, so available memory address lines of memory chip with those of the microprocessor. Also connect the memory read and write input to the corresponding processor control signal. Microprocessor 8086, it is having two signals, one for read, one for the memory write. For memory read, it is having MRD, and for memory write it is having MWR for memory read and for memory write. Okay, so these signals will be connected to the read and write signals of the memory chip. So the read and write signals of the memory, they will be connected to the corresponding processor control signals. Okay, so this was our second step. Now address lines of the microprocessor and the memory device, they are connected to each other. Then data lines also, they will be connected. Here we have connected the address lines, and the read and write signals are also connected, and data lines are also connected. That is from D0 to D7, 8 data lines are here, and for microprocessor we are having 16 data lines, D0 to D15. So one will be connected with the odd memory, and the 8 will be connected with the even memory. Okay, so suppose here we are having the odd, this will be the even. Okay, so these remaining data lines D8 to D15, they will be connected to the second memory chip. Okay, Now in the third step, the remaining address lines, that is for the case of 4 kilobyte of memory, we are taking A12 to A19. So the remaining address lines, we can say N minus P address lines of the microprocessor plus the bus high enable. In the case of 8086 microprocessor, we have a signal bus high enable. This signal and the A0 signal, these three, that is remaining address lines BHE and A0, these three will be used to decode the required chip select signals. So here we can say the bus high enable, the N minus P address lines and the A0 signal. These three signals, they will form the chip select signal. Means the memory chip will be selected, the CS bar signal will be generated by the combination of these three. We can use logic circuit, logic gates here, we can use decoder, encoders to generate the chip select signal. So we will here use some logic circuit, logic gates and decoders to generate the chip select signal. Now the chip select signals, they will be generated for the odd and even memory banks, because we are having 8-bit data available at odd memory bank and 8-bit data available at the even memory bank. So for all both the odd and even memory banks, we are going to generate separate chip select signals. So using these three, we will generate chip select signal for odd also and for even also. Okay, and this chip select signal, it is derived from the output of the decoding circuit. Here the decoding circuit, it can be a logic gate or it can be a decoder. So the output of that decoding circuit, that will be the chip select signal. So these are the three steps which we are going to follow whenever we will interface a memory chip with the 8086 microprocessor. First, we will find out that how many address lines are required to address that memory chip. Then we will connect those address lines with the address lines of the microprocessor and the memory chip. They will be connected, data lines will be connected. We will arrange the memory location so that we will get an 8-bit odd memory bank and 8-bit even memory bank. Okay, then chip select signal will be generated using the three signals BHE, A0 and the remaining address lines, and that chip select signal will be generated for both the odd and the even memory banks. So in this video, we studied about the interfacing of the memory chips with the 8086 microprocessor. We started with that what is a memory, what are the types of memory, RAM and ROM available in the microprocessor, what is the structure of a simple memory device. It consists of address, data lines, selection input and control inputs, and how we can interface a memory device with the 8086 microprocessor. So I hope that this topic is clear to you. Thank you.